This is on page 692. So 1, 3, and 5 is basically an entire chi-square test. So let's go ahead and do it. So here's our null hypothesis, is that no change, right? That what the company says is what the can of nuts has, right? No change. Alternate hypothesis, which is what we're trying to prove, is at least one of these is incorrect. There we go. So let's do the expected counts. So here we go. Well, if we look at the numbers here, we could just add them up and see what we got. So there's 150 total. I'm going to multiply each one of these probabilities by 150 and see what we get. So this is what I get. And so for the cashews, 78 is what we expect. We had 83. For the almonds, we had 29. That's what we saw, but we expected 40. Macadamia was 20. That's what we counted. We expected 19.5. That's about right. And Brazil nuts was pretty close too. We saw 18 in this can of nuts that we had. Expected about 12. So now let's do the chi-square. Okay, so what do? It's observed minus expected. So 83 minus 78. And we square that and divide by the expected. We add to that. It would be 29 minus 40.5 divided by 40.5. Don't forget to square the top there. Crud, I'm not going to make it. 20, dang it, and minus, what is it, 19.5. Square it and divide by 19.5. And the last one, which I'm going to have to put on the next line. Wait, do I? Or could I just slide it over? What? Technology? Still doesn't fit. I'm going to make it fit. So, and then the last one is, what was it, 18? 18 minus, we expected 12. Square it. Divided by 12. Add this whole mess together. And what do we get? So we get the chi-square, right? That's what we're trying to figure out, is 6.6. So are all the expected counts bigger than 5? Let's check that. Yes. Okay. Is the sample size bigger, 10 times bigger than 150? Probably. Does it come from a random selection of nuts? Yes. We're just going to assume all that stuff, right? Okay. So there we have this. What would the graph look like? Let's see if I can, oh wait, move this stuff up. Woo. And let's see. So we had 4 categories, right? So if we drew the graph, the hump, right? And it's skewed way over here, that would be around 2, right? But our number is at, so that'd be 1 and 0, 3, 4, 5, and 6. So probably out here, 6, like that. So what are we going to do? Aha! 6.6. Let's do that. Was it chi? Let me look it up again. Second distribution. Chi-square CDF. So our low number is going to be 6.6. High number is 100. Degrees of freedom. We go 1 less than the number of categories we had. We had 4 different nuts. Now we have 3. And what do we get? So our p-value is going to be 0.08, 0.085. Okay, what do we do with that? Well, that's bigger than our alpha level since it's not stated. We're going to say it's 0.5. It's bigger than that, so we fail to reject. We would have about an 8.5% chance of having a mixed nuts like this if what the company says is true. So we fail to reject the null hypothesis. We do not have enough information to say that one of these probabilities of nuts in a can of nuts is off, right? That it's wrong. So there it is.